There is a storm at Saturn's north pole shaped like a hexagon. 6 straight sides, 6 corners, unchanged for at least 45 years. And directly above it, something has been quietly fooling every instrument we have ever pointed at this planet. Stay with me, because researchers just worked out what it is. And subscribe while you're here. Everything on this channel comes from published research, with the hype left out. There is more happening at Saturn right now than most people realize. Start with the hexagon, because it is the part you can actually see. Voyager founded in 1981, and it has been sitting there ever since, holding its shape while everything around it moves. Storms on Earth are spirals. They wander, they collapse, they reform somewhere else. This one has straight edges, and it has not moved in the entire span of human observation. In March of this year, Webb and Hubble released a set of Saturn images taken together. Hubble's visible light view, captured in August of 2024, picks up subtle color variations across the banded clouds. Webb's infrared view, taken on the 29th of November that same year, senses clouds and chemistry at many different depths at once, layers stacked on top of each other rather than a single surface. The hexagon is faintly visible in those images, and that matters more than it sounds, because scientists believe these may be the last high-resolution views of it until the 2040s. The northern pole is tilting away into a long winter darkness, and when it goes for about 20 years. A weather pattern older than every photograph ever taken of it is about to disappear from view, and there is nothing anyone can do about the timing. But the pole gave up something else on the way out. In those same infrared observations there is a gray-green glow sitting over the poles, most likely tied to high-altitude aerosols and auroral activity. And to understand what Webb found in that glow, you need to know why nobody had managed to look at it properly before. Webb does not photograph a planet. It splits incoming light into individual wavelengths and reads the temperature and density of separate atmospheric layers out of the pattern. The problem with Saturn's upper atmosphere had always been precision. Earlier measurements carried errors of around 50 degrees Celsius, roughly the same size as the differences researchers were trying to detect in the first place. They were hunting for something with a tool blunter than the thing they were hunting. If you want more of this kind of thing, a like genuinely helps. It is the difference between this video finding the people who care and quietly disappearing. The mystery it finally solved is 45 years old. In November of 1980, Voyager 1 measured how fast Saturn turns and got roughly 10 hours and 40 minutes. That became the number. Then, Cassini arrived in 2004, pointed its radio instruments at the planet, and measured a period about 6 minutes longer. And over the following years, the readings kept shifting. 6 minutes is not a rounding error in planetary science. It is a different planet. But the alternative was worse, because planets do not change their rotation rate on short timescales. There is no mechanism for it. So the field was left holding 2 options, both bad. Either Saturn was doing something impossible, or every measurement since 1980 was wrong. In 2021, Tom Stollard, professor of planetary astronomy at Northumbria University, argued for the second one. His team's work showed Saturn's rotation had never changed at all. High-altitude winds in the upper atmosphere were generating electrical currents, and those currents were distorting the auroral radio signal everyone had been using as a clock. The planet was steady. The measuring stick was wobbling. That solved one problem and created another. If winds were bending the signal, what was driving the winds? For 5 years, there was no answer, because no instrument could resolve the region finely enough to look. On the 29th of November, 2024, Webb's NIRSPEC instrument was pointed at Saturn's northern auroral region, and held there continuously for a full Saturnian day, from 4 in the morning until just before 2 in the afternoon, universal time, without a break. The team analyzed the infrared glow of trihydrogen cation, a molecule that forms high in the atmosphere and behaves like a natural thermometer. What came out were the first spatially resolved maps of temperature and density across that region, under 500 kilometers per pixel, at least an order of magnitude better than anything before it. The results were published in March of this year in the Journal of Geophysical Research, Space Physics, with Stollard as lead author. And the answer is a machine. The aurora heats the atmosphere. The heated atmosphere drives winds. The winds generate electrical currents. The currents power the aurora. And then it starts again. Stollard describes it as something like a planetary heat pump, a system that supplies its own fuel and has apparently been running that way for a very long time. The man who claimed in 2021 that all the clocks were wrong spent 5 years unable to say why, and then proved it himself. This reaches further than one planet's spin. What the maps show is a two-way relationship between an atmosphere and a magnetosphere. Energy does not simply flow inward from space. The atmosphere pushes back and helps shape conditions around the planet. That may be why the effect has stayed so stable for so long. It also means something uncomfortable for anyone measuring a gas giant from a distance. If an aurora can bend a rotation measurement by 6 minutes, every remote reading of that kind deserves a second look here and around other stars. Now leave the planet, because the strangest thing in this system is not on Saturn at all. It is on Titan, Saturn's largest moon and the only moon anywhere with a genuinely thick atmosphere. A team led by Beeb Zard was working through Webb's spectra of Titan when they found an absorption feature at 5.113 microns. Something down there is swallowing light at that exact wavelength, and it is not subtle. The dip runs 6 to 7% deep, showing up in both NIRSpec and MIRI data, so they went looking for what it was. They ran radiative transfer models loaded with every gas and haze particle known to exist on Titan. In the models, the absorption simply does not appear. Then they searched the published laboratory work for any compound that absorbs at that wavelength: ethane, ethylene, acetylene, propane, the whole standard inventory of Titan chemistry. Nothing matches, and then it got worse. The same signature, roughly 3 times broader, sits in the MIRI spectrum of Pluto, 4 to 5% deep. 2 worlds with almost nothing in common, carrying the same unexplained fingerprint. Before anyone reaches for the obvious guess, this is not evidence of life, and the researchers do not present it that way. The more interesting reading is quieter and stranger. Titan's thick nitrogen and methane atmosphere makes it extremely difficult to study what the ground is actually made of, and the chemical composition of that surface remains very uncertain. So the likeliest explanation is not that we found something impossible. It is that Titan is running a chemistry we have no catalog for, that's somewhere in a lab on Earth. The spectrum of this compound has simply never been measured, because nobody knew to look. And the fact that it appears on Pluto too suggests it is not a local accident, but something these frozen worlds make routinely. We landed a probe on Titan 20 years ago. We do not know what the ground is made of. Part of the reason is that we left. Cassini arrived in 2004 and spent 13 years working the Saturn system, and in 2017 it was deliberately steered into the planet's atmosphere and destroyed, so that it could never contaminate the moons it had been studying. It was the best instrument ever to reach Saturn, and it was sacrificed on purpose. Nothing has been there since. Everything we have learned in the years after came from telescopes sitting over 1 billion miles away, which is why a 45-year-old question about how fast a planet turns took until this year to answer. Saturn never sped up and never slowed down. It spent 4.5 decades misleading every instrument we aimed at it, and the thing doing the misleading was its own northern lights. A machine at the pole, feeding itself, hidden under a hexagon we are about to lose sight of for 20 years. The mistake was never in the planet. It was in assuming that a signal arriving on a regular schedule must be measuring something regular. Subscribe if you want more of this, because Webb is still looking. Thanks for watching. I'll see you in the next one.